So let's solve an example for buoyancy. Here we have a 15 kilogram solid gold statue and it is being raised from a sunken ship. So what is the tension in the hoisting cable when the statue is at rest and A, completely immersed, and for B, when it is out of the water? So for A, for example, here is the ship, this is the hoisting cable, and this is the statue. So A, it is completely immersed, and for B, it is out of the water. So walang water dito. So if we try to solve for both scenarios, we would need to draw first diagrams to solve this problem, because we are interested to solve for the tension here. So let's draw first diagrams. So in this statue, we have tension, we have its weight acting on it, and now that since it is submerged in water, there is also a buoyant force that is acting upward on it. So in the case that it is out of the water, the forces acting on it is tension and its weight. So there is no buoyant force outside the water. So let's solve for both equations. So since this is a static case for both scenarios, so let's solve first for A. So scenario A, the summation of forces acting on the gold statue must be 0. So these forces are buoyant force plus tension minus the weight. So what is the buoyant force acting on the object? So if you would recall, buoyant force is equal to the density of the fluid times the volume that the object displaces on the fluid times G, and then plus tension minus mass of the gold statue times G. So if we will isolate T here, T will be equal to mg minus rho times V times G. Now, question is, what is the volume displaced by the statue? So if you would imagine, again, if you will, a glass full of water, and you submerge the statue inside that glass full of water, the volume displaced is equal to, well, just the volume of the statue. So this is equal to volume displaced. Now, this reduces to the problem of what is the volume of statue? Because if we know the volume of the statue, we will know by how much volume is displaced in the water. So what is the volume of the statue? So let's pause for a bit in this equation and let's try to find what is the volume of the statue. So volume of statue is equal to what's that equation? Mass over volume. So volume of statue is equal to mass of the statue over density of statue. So take note, this is density of the statue, not the fluid. Okay, so let's bring this expression back to this equation. So now T will be equal to mg minus rho. So I will put rho of water times mass of statue over density of statue times G. So this is V. This is volume displaced. Okay, so I will remove the subscript statue because this is also M, or the mass of the statue. So T is equal to, we can factor out mg 1 minus, so this has a term mg here, density of water over density of statue. So this is our equation that will solve for the tension when submerged. So let us solve. T is equal to, mass of the statue is 15 kilograms times G times 1 minus density of water, which is equal to 1000 kilograms per cubic meter, over the density of the statue is equal to the density of gold. So this is 19,300 kilograms per cubic meter. So this is already converted into kilogram per cubic meter. So if you would try to solve, put in your calculators here, you would get a value of 139 newtons. So this is if submerged in water. So I will leave it to you to solve what if it is submerged, if it is out of the water, and solve for the buoyant force.